The person who invented the supercharger is really smart. The existence of the supercharger greatly improves the performance and power of the engine. So which one is better, supercharging or turbocharging? In this issue, we will use 3D anatomy technology to take a look at the working principles of these two superchargers. Please don't go away. Whether you want to buy a car or own a car, you can learn about it. First, let's take a look at how turbocharging works. You can see that the turbine is connected to the engine exhaust system, and the exhaust pipe is specially designed for turbine placement. The turbine has two separate compartments called the turbine section and the compressor section. When the heat and pressure drive the turbine or exhaust wheel, the exhaust gas flows through the turbine part. The upwind shaft exhaust wheel is connected to the compressor wheel. The compressor wheel sucks air through the air filter and the intake pipe. Its specially shaped blades force the air through smaller and smaller cavities and create a compression process. Air heats up during intake and compression, so most turbo setups have an intercooler between the turbine and engine intake to bring the air back to ambient temperature, since cooler air has a higher density. This helps force more air into the engine. Intercoolers work similarly to radiators. As outside air rushes through, the hot air passes through internal ducts to be cooled. At present, the common turbine types we have are the single turbo type, which flows all the exhaust gas into a single turbocharger, and the twin turbo type, which is generally used on V-shaped six-cylinder engines. Let's take a look at how supercharging works. It is located at the top of the intake manifold. A belt transmits the crankshaft power to the supercharger pulley. A gear train transmits the input power to the opposite rotor. Outside, air enters the interlocking rotors through the air filter and intake duct, forcing the air through the supercharger's long fins spanning the length of the rotor shaft to break into lobes of air and through specially shaped exhaust ports at the bottom of the housing. The supercharger exhausts the air, which is the principle of mechanical supercharging. Let's introduce the different common types of superchargers, which are centrifugal superchargers and twin-screw superchargers. The design concepts have many similarities, but they are indeed mechanically driven. Centrifugal superchargers feature an exponential power curve adjustment that is fully boosted at the engine's redline, while twin-screw superchargers have a complex blade design that effectively compresses the air as it passes through the device. Everyone must have a certain understanding of mechanical supercharging and turbocharging. Simply put, supercharging is powered by mechanical energy through the crankshaft connected to the engine, while turbocharging is powered by the engine exhaust. The wasted heat energy in the air provides power. Superchargers have a positive displacement, can achieve immediate boost even at low speeds, and have a fairly linear power curve. Turbochargers create an exponential power curve. Because the turbine is powered by exhaust gases, it takes time to build turbine speed and pressure before usable boost is produced, a delay called turbo lag. Turbocharging is more effective than supercharging in high-power engines and also allows for better attempts at boosting. The rich play self-priming, the poor play turbine, and only madmen play surge. If it were you, what would you choose? Like, comment, share, and follow for more informative 3D videos.